All right. Hi, everyone. We are live today, so really excited to be here with you and excited to have a guest with us who's, well, been with us before. Henri, welcome to the live stream.
Thanks.
All right. Now, if you give me a few minutes, I'm going to sort out this presentation. So welcome, everyone. Very exciting day, and I apologize for anyone that was here last week. We did have a quick change of the date as we're waiting for some things to come through, but we're here now, and we're super excited to be able to release the 2022 State of Secrets Sprawl. So give me a minute. I'm just going to share my screen. Will this be available on demand? Yeah, we'll be able to watch this on demand. Now, I do want to let anyone know watching on YouTube, we're streaming this in two places, Crowdcast and YouTube. So if you want to participate, there's going to be a lot of polls, prizes, you can ask questions. You have to do that in Crowdcast because we're not going to be monitoring YouTube because I can only monitor one thing at a time. There is a link in the YouTube channel of how to get across to Crowdcast if you want to come across over and ask some questions and participate. We're going to do some intros. We're going to talk about the State of Secrets Sprawl report, and we're going to break it into three categories: public Git repositories, public Docker images, and internal repositories. So while we wait a few minutes just for everyone to kind of come online, I can see there's quite a few of us now, but just to let everyone know that there's going to be prizes. Now, we have swag bags usually, but this time we've upped it with Amazon gift cards. Henri, you cannot win an Amazon gift card.
Too bad.
Anyone at GitGuardian, you're banned. But we're going to be giving away swag bags for participation, and we're going to be asking a lot of questions. If you get the questions right, you can win an Amazon gift card. Just to clarify, not everyone that gets it right will get one. We'll pick a random winner. So let us know in the chat, because this is my favorite part. I always like to know where everyone's tuning in from. So let us know in the chat where you're tuning in from. Love to find out. We've already got a couple here. I can see Sunny PA. Myanmar. Wow, cool. Welcome. Manhattan. Denver, Florida. London. Netherlands, Goedenavond, Tel Aviv, Greece, Rwanda, hey, that's awesome, Alabama, Munich in Germany, Canada, France, bonjour, bienvenue, California, Canada, India, wow, Kenya, some cool, a few people from the African continent, that's great. Paris, we are also tuning in from Paris. Denmark, Lyon. Wow, some cool places. Iran, oh wow, we're really getting across the board here. So, and a lot of people from Canada, Uruguay. Ah, very cool. All right, so let's kick this off. So what is the State of Secrets Sprawl report? So each year, GitGuardian does an annual report where we look at all the secrets that have been leaked, that we've discovered, and we publish our findings about that. Now, this year's a little bit different. Last year, we looked only at public GitHub repositories, so all the commits that were made to GitHub. This year, we extended that. We're looking on Docker Hub, Docker images, and we're also looking at internal private repositories that GitGuardian is monitoring. So we're extended this analysis. So it's going to be pretty exciting, and we're going to have some great results. So some quick definitions you can read on the screen if you're unsure. But when we're talking about secrets, we're talking about digital authentication credentials. So Henri, what are some digital authentication credentials that we have?
You have passwords at first.
Yep.
That can be used either by humans or by computers.
Yep.
You also have database credentials, and finally you can have like security certificates. You have API keys, obviously.
Right.
And that's most of the secrets that you can find.
So anything that kind of authenticates a person or a system to another service.
Yeah.
Okay. And secret sprawl, we talk about this a lot. What's secret sprawl?
Secret sprawl is about the secrets being sprinkled everywhere. Like you have a secret and then it ends up in your code, in your systems, in your computers, in someone else's computer, everywhere.
Okay. So like when we think about secrets, it's something we obviously want to protect and we want to know where our secrets are.
Yeah.
And secret sprawl is when we basically lose control of that. Okay. So there's some quick definitions going through. Now, the next thing I want to talk about, Henri, is our methodology in trying to find these secrets. So we're going to release some pretty staggering numbers and some pretty large numbers. How can we be sure that they're actually correct? What is the process that we go through to be able to detect these secrets?
Yeah, so the process we go through for repositories is that we take every commit of a repository and we will scan its content, so basically code, and we will try to find patterns that are related to secrets, like patterns for AWS keys, for Google keys, for security certificate. We will go through that and so we will find secrets. So that's the first method that we use. It's called specific detectors because we know to which service it relates.
Got it.
And then we have what we call generic detectors that acts like a safety net that allows us to find secrets for which we don't know the services they're related about. And it's just based on context. Like you find something called secret with a high entropy and it's in a code that is related to secrets because it calls, let's say, a database. And then because of that, you can be pretty sure it's a secret.
Okay. Okay. So specific detectors, generic detectors. How many specific detectors do we have?
We have about 350.
So 350 different types of secrets, not including the generic detectors that we're discovering. How many did we have last year on last year's secrets?
We had 250.
Okay. So we have a lot wider search this year than last year. Will that affect the results at all?
Yeah. It will affect the results a lot.
Okay, so that's something to keep in mind when we're comparing these, especially to last year, is that because we've widened our capabilities of detection, we've also increased the amount of numbers that we've discovered. Okay, now I want to talk about the final step, validation. There's a lot of developers out there that will put kind of what looks like a secret in their code, but maybe change some characters just so that this is an example. Is there a way that we can filter out those results?
Yeah, in some cases we do actually use what you call validation in order to filter those dummy credentials.
Right.
And this is done by making a non-intrusive API call to the provider. So
right.
Obviously we have to know the provider. It doesn't work with generic detectors.
Yeah.
And depending on the result, we then know if the secret is still valid or if it's invalid because it has been revoked, or if it's a dummy credential by a developer trying to obfuscate it.
Got it. Okay, so we can be pretty confident in the results that we have, that we hear, and obviously in our results we remove multiple occurrences. So when we give out numbers, these are unique occurrences, not multiple occurrences.
No, we count occurrences.
Okay.
In fact.
So let's start with public monitoring. So public monitoring is github.com, is what we're monitoring on github.com. And we scan every single commit. Is that right? Every single commit that's made.
Yeah, every new commit goes through our scanner and we detect secrets in it.
Right. And how many commits a year are we looking at here?
More than 1 billion.
More than 1 billion with a B?
Yeah, with a B.
Well, that's a lot of commits. Okay, so we have our first poll here. So just coming across. How many secrets do you think were discovered in 2021? So here are the results. Down the bottom, there's a polls tab. So if you click on that, you will see there. And we have a bunch of polls, and they'll become visible as we go. So we have 21 votes here. 23, a few, okay. So we're getting in. Consensus seems to be 5 to 6 million. So we'll see. Now, just as a reminder, let's have a look at what we found last year. So last year, we found 2 million secrets, a billion commits scanned, and this was about a 20% increase from the year before that we could detect. Okay, so I'm going to give everyone a few minutes to get their polls on, and I will do a cutoff of that. Okay, so Henri, I'm going to let you do the honors if you give me 1 minute. How many secrets did we find in 2021?
In 2021, we found 6 million secrets.
6 million secrets. So that's interesting because when you're looking at the polls here, that's the consensus, 5 to 6 million. 51% of people thought that would be it. So I'm impressed. Well done. So that's a huge increase in secrets that we see. So we have here 6 million secrets detected, and we're saying that this is a 2x increase from the previous year. Now, I'm not known to be amazing at maths, but 2 million last year, 2 times 2 does not equal 6. So can you walk me through how we computed this and how we ended up with that figure of 6 million and 2x?
Yeah, there are several effects. The first one is that last year we announced 2 million secrets, but it was a conservative estimation. Mm-hmm. And we took this number and recomputed it, and we found 2.6 million secrets actually.
Right.
So that's the first part of the increase. And the second one is that the volume on GitHub raised also by 23%. So we had more commits to scan, and we found more secrets this year.
Okay.
And this leads us to the 6 million.
So when we compare apples to apples, then obviously we get to a 2x increase of 6 million.
Yeah.
Okay, perfect. I'm on board now. Okay. So we have some other numbers on here. 56 million users. Now we have here 25% increase in repositories created last year. So 25% more repositories on GitHub. And we increased our scanning by 23%. Now, are these numbers correlated? Why aren't they both the same? If we're talking about increase in repositories, shouldn't we see the parallel increase in commits?
They are obviously related, but they can be different. And in fact, they are different because we could say that developers may have not created any new repositories this year, mm-hmm. but still continue to commit on the existing repos, which
right.
would have led to 0% increase in repositories and 23% increase in commits.
Got it.
So those numbers are quite similar because the developers haven't changed the way they work. Like they still continue to create new repositories with new commits.
But they're not necessarily completely correlated.
Yeah.
So we can see a big difference. Come a bit closer. You're falling out of the frame there. All right. So we get to the first exciting part of this webinar. We can announce the first winner of an Amazon gift card. So I am just going to find here a random person that we can have. So I have Joanne G. from Washington, United States. Congratulations, you just won a $50 Amazon gift card. Now I will get in touch with you after the webinar to let me know. You got the correct number right, along with about 50% of you. So sorry to everyone that missed out on that, but don't worry, we have more opportunities as we're going through. We've got a lot more to discuss. So let's go through here. So the next, what we're looking at here, Henri, is we're looking at the secrets that leaked by categories. Okay, so obviously we have 350 individual detectors, we have generic detectors. We can't list everything because it's an extremely long graph. So we've broken it into categories. What can you talk me about the categories? What can we find in each of these categories, for example?
Yeah, I think most of the categories have a name that is kind of self-explanatory,
Right.
like data storage is related to databases.
Got it.
The one that is interesting is the other category.
Okay.
The other category first has all the secrets that are in none of the previous categories, but there are also the generic detectors, where we cannot really know the topic they are related to.
Okay, got it. All right. So how does this compare to last year's State of Secrets Sprawl? So, I mean, right off the bat, I can see we got a huge difference in the other category. So how can you explain that massive jump from 12% was other last year, 32.8% is other this year? How do we get to that computation?
Well, in the past year, we had huge effort on secret detection about generic detectors.
Right.
Because they allow us to increase by vast amounts the range of detection. So this is why you have those numbers for the other category.
Okay, excellent. I understand that. And then we've seen some other shifts in there, but I guess because the other category has changed so drastically, it's kind of hard to provide any analysis on the rest that we've discovered. Okay. So we have another poll here. I'll just check that it is live. How many GitHub tokens, so we're specifically talking about GitHub tokens, were discovered in the commit message? So this isn't the code. This is in the message of the commit. So I'm going to give everyone a few minutes to kind of go through this. All right. Interesting. 31 votes for plus 600, 11 votes for 200 to 599. One vote for none? Surely not. I like that person's optimism. And a couple of votes for just a few. All right. So if you give me 1 minute, we're going to open up here and we're going to find someone with the correct answer here. We're going to actually, I lied. We're going to combine this with the next poll as well. Okay. But if you want to know the answer, how many did we find?
We found 500 commit messages containing GitHub tokens.
500.
Yeah, 500.
Can you walk me through why a GitHub token would be in a commit message?
I have no idea. I have strictly no idea.
Could it be like a mistake thinking that we need to authentication mistake, thinking that the commit message, we authenticate ourselves with GitHub? Perhaps it's a copy and paste error. All of the above, anything?
Yeah, I would go for the copy paste.
Okay.
But I have no idea.
What does everyone think? Does anyone have in the comment section any reasons why someone would commit, obviously by mistake, but...
Maybe someone did.
Maybe someone did. You can let us know. Don't admit to that. All right, let's move on. Okay, so now we're going to have a look at cloud providers, because here's some interesting stuff. So we had cloud providers as a category, so let's hold this for fun. Elliot, I'm not liking the way that your definition of fun. Okay, so let's have a focus on some cloud providers. I was distracted. We see here a bunch of different cloud providers. So we've got Google Cloud, AWS, Azure, Alibaba, Scaleway. Now, here's something interesting. There's a lot of kind of massive developments in this, but we can also see that there is a decrease in AWS keys. Can you walk me through why we're seeing a decrease in this? Is it positive, or are people using AWS less? Is it something to do with the market, or are we actually seeing improvement on this?
I don't think people are using AWS less. I think it's growing. It's always growing. But on the other hand, I think that people are more aware that AWS keys are sensitive.
Right.
Because everyone is advertising about AWS keys being sensitive. Like, it's always the example we take for secret detection, and people get used to it and they understand that all AWS keys should be kept private.
Right. I think there is definitely a huge movement there. And it is always my go-to example. I did a video on what actually happens when you leak an AWS key in GitHub. So it's on our YouTube channel if you want to check that out. Spoiler alert, it was started to be exploited within a couple of minutes from bots. So the fact that everyone's looking for these keys, the fact that there's a lot of information about sensitive. So we're winning a battle here. We're starting to see that some improvement in this. Can we pull that? Can you give me that piece of good news from this slide?
Yeah, we are seeing some improvement.
Okay.
Unfortunately, only on AWS keys.
Okay, here we go. Now moving along. Now here's some names that maybe you don't recognize, everyone in here. We've got PlanetScale and Supabase. So these are cloud providers, correct? And they're fairly new. And we're actually seeing some increase. So this graph here, same as the other one, is the number of detected secrets per 1,000 commits. And we're seeing an increase in this. What can we kind of extrapolate from this data? What are we kind of seeing here with the increase in these secrets?
We are seeing an increase of popularity of the systems,
okay,
first. And then we also see that it's important to have secret detection that is aware of the new providers or have ways to detect new providers, such as generic detectors.
Right, okay. So what we're seeing here is that we can't just focus on AWS, we can't just focus on TCP, we need to have very wide range to capture these new types of secrets that we're using. And as we see, so I mean, this is a good thing that we're seeing an increase for the companies because we're seeing an increase in their services being used. But then we also have now the danger of these keys being leaked and kind of the opposite of AWS, that we don't have that awareness around these keys yet. Okay. New poll. So I think this one's visible. Yes, it is. Okay. What days of the week do we lease the most in a second? This is a fun one. Okay. There's a prize at the end of this one. I tricked you on the last one. I promise. A prize for right answers this. If you got both of them right, we'll increase your chances. Okay. What days do we leak the most amount of secrets? So we have Mondays because we're tired from the weekend, depending on what your weekend is like. I'm tired on Mondays. Wednesdays, we've got the hump day blues. Fridays, because we're getting ready. Mine's back on those good old Friday releases. We love them. Weekends, we're working on some personal projects, or all days are relatively equal. There's no clear data on what is winner. What do we think? Okay, interesting. Fridays is winning at the moment. Fridays is definitely winning at the moment. So we'll have a quick. I'll give you a quick minute. So 24 votes for Friday, 8 votes for Monday. Okay. Here we go. The winner of this is weekends. So, weekends we have the most amount of data committed. This seems counterintuitive to me. Why are we seeing so many leaks happening on weekends? And, as the slide shows, if we exclude weekends, then we're seeing a lot on holidays. So, is there any relationship here? Why is this phenomenon?
I think, I'm not sure of that, but my hypothesis is that people work more on open source projects or personal projects that are more likely to be public during the weekends.
Okay. So that makes sense also for the holiday phenomenon. If they're working on personal projects, is there still a risk of a lot of these keys being corporate keys? Or would we see that these are mostly, nearly all, personal keys? What can we kind of see there? Is there still a risk of corporate keys leaking on the weekends?
Yeah, there is still a risk, especially in those COVID times where people tend to work from home and maybe share some devices between work and their personal usage. And because of that, the risk of making a mistake, like copying the wrong file, using the wrong secret, is huge.
Okay. That makes sense. All right, I found someone that got both the last two questions right. So we have another AWS gift card to give away. All right. So we have Par from Bangkok, Thailand. Par, congratulations. You just won a $50 Amazon gift card. So congratulations, Par from Bangkok, Thailand. Now, I just want to send out a quick reminder to those that may be viewing on YouTube, is that if you want to participate, if you want to win prizes, you have to come across to the Crowdcast live stream. There's a link in the description. So if you're screaming into the YouTube chat and wondering why no one's listening to you, that's why. Okay. And you can ask a question. We'll get to those at the end. There's a questions tab. I see that we have a couple. So feel free to ask questions. We will get around to them. But also you can ask questions in the chat. We won't see them at the moment, but we do have members that can answer that there too. So feel free to ask some questions in the Ask a Question section. That will help you win a swag bag. And also in the chat if you wish. All right, so let's talk about Docker. So Docker, this one is quite interesting. Can you explain what a Docker image is to start? Let's start there.
Well, a Docker image is some sort of copy of a file system of a computer that can run on mostly any computer. This allows you to build an app and then share it with other people, other computers, and it will run perfectly.
Okay, I got it. So it's kind of like a virtual machine, but a lot lighter.
Yeah, a lot simpler. Yeah.
Okay, I got it. So we started scanning Docker images last year as well. Now, unlike GitHub, where we scan every commit, we don't scan every Docker image that comes through, correct?
No.
Okay. But there are 8.8 million Docker images on Docker Hub, and we scanned 10,000 of them. Now, we also did a smaller experiment earlier on in the year, which you were part of that webinar. We've done a much larger experiment this time. Can you walk me through these results of what percentage of Docker images contain secrets?
Yeah, so on those 10,000 images, we found that 4.6% of the images contained secrets, at least one. And this resulted in 4,000 secrets found. Right. Well, 4,000 occurrences.
Okay, got it. That's a lot. So 4,000 secrets, 1.2 thousand unique secrets. We have here an interesting stat. So we have 6 secrets per 100 layers. Okay, so what is a layer, and why are we computing secrets per layer?
Layers Docker images are composed of layers that are built one upon each other. And so we thought this stat would be interesting because you can compare it kind of like with commits.
Okay.
Like commits are built on top of each other, and so do our layers. And the secrets can be hidden in a layer that is not the top one, so that you don't see in the current state of the image, but it's still there in the history. Okay,
I got it. So layers like GitHub. So if I make a commit on a repository, I submit a secret, I remove that secret and commit over it. That secret still is in the history. Layers are similar. If I'm building a Docker image, I add a secret in to connect to, let's say, a package manager. I remove that secret. It's still in my image layers, correct?
Yeah.
Okay. So comparable to commits, there's that layers. Really interesting stuff. Do we see the same type of secrets in Docker that we do in Git repositories?
It's not exactly the same type of secrets.
Okay.
We tend to find a bit more infrastructure-related secrets, such as Terraform tokens, AWS keys, because Docker is more tied to infrastructure than code in general is.
Okay, I got it. So more infrastructure type secrets, and that makes sense. Another poll. Now I saw some chat about this too, and we have some conversation with this particular result. So what country leaked the most amount of secrets? So India was last year, so we're going same as last year. USA coming up, Brazil, Nigeria, and France. So these were all in top results of last year. Perhaps we're going to see a completely new player. So let me just check. We have the poll. Yep. What countries? India and USA. No one's guessing France. There we are. All right. So let's have a look here. India, still number one. USA has moved up, actually. Germany, France. So we've had some different results here. The main one is Brazil's moved down from 2nd to 9th. So that's a big drop. What does this tell us about? Like the countries that are leaking these secrets? Is it India bad, or is there other factors that are handling this?
It's absolutely not what it's saying. Like, India is not bad. Actually, India is probably the country that commits the most on GitHub.
Right, okay.
This map is more related to the activity of the developers in those countries and the number of developers, rather than if they are good developers or bad developers.
So when we see secrets being leaked, do we see it from a specific type of person? Is there a specific profile that leaked? Is it junior, senior, AppSec, or is it everyone?
It's everyone.
Okay. So a lot of it comes from human mistakes. So we can get some good information from this, so that India is actually committing a lot from this. They've got large engineering populations. They've maintained that number one spot. And I'm going to argue that this isn't necessarily a bad thing. It doesn't reflect that Indian developers are bad or leaking more. It just indicates that there's more developers in India. So I think that's an important process to make when this slide here happens. Okay, some questions. Okay, so we're actually going back to this question here. Is this Docker or is this public? So this is the public information, just trying to spread out some of the polls here. So not just Docker, this is across the board. All right, so who is going to win? So let me have a look at this. Let's find another winner. It takes me a few minutes to sort through the results. So give me 1 second, and we're going to find someone. Okay, I have one. So we have Nlush from Nepal. Nlush, N-L-U-S-H. I'm sorry if I'm pronouncing that wrong. You can ask Henri. My name's quite bad. But anyway, so congratulations. You've won a $50 Amazon gift card. I'll contact you I'll contact you after this webinar and let you know how to prize it. So congratulations, Nlush, you got the question right. And congratulations to everyone else that got it right and didn't win a prize. So I apologize about that. Okay, so let's move away from public stuff. So we talked about public Docker, we talked about public GitHub repositories. Let's change the conversation. Let's have a look at internal. So maybe a quick, just in case, I'm sure we're all aware, but what's an internal repository compared to a public repository? I mean, it sounds obvious, but
yeah, what we call an internal repository is a repository that is not open to anyone on the internet.
Right.
Mostly they are from private projects, from organization projects. Yeah, it's everything that's not open source.
Okay, I got it. So this is something that you obviously see a lot of. You're working with a lot of companies, you're working on a personal project, you gotta make it internal. Yeah. Okay.
On this analysis, we only focused on repositories owned by organizations.
So repositories owned by organizations, and this is organizations that are scanning the code with GitGuardian. If you're wondering if we have access to your private repositories, we don't. But if you're using GitGuardian, we take those results from there. All right, so let's have a look at some of the information about internal repositories. So we've made a big focus of this in this year's report, internal repositories, and we're focused on the AppSec engineers a lot. So there's some big numbers here, but I want to focus on to the left of the page first. So we have 1,050 unique secrets were leaked upon scanning a repository and a commit. So this is referring to a company with 400 developers and let's say roughly 4 AppSec engineers. So is that a lot? Is that not a lot? What can we see from this?
Well, 400 developers is quite a big company. It's not a huge one, but it's already a big company.
And for a company that size, is it okay to have 1,000 secrets in your repositories? Is it bad practice? What can we say? And then, yeah, so maybe answer that, then I'll have another follow-up.
Well, obviously, it's a bad idea.
Okay.
But it happens, and it's in the, let's say, I won't say like normal, but it's usual.
It's usual.
Like,
so why is it a bad idea? I have my private repository. Let's say I even have multi-factor authentication on it. So it's not public. And I trust GitHub, or I trust the version control system that I'm using, that they're not going to they're not going to leak that information. Why is this a problem? Why shouldn't I have secrets in the private repository, in an internal repository?
in most companies, the code is shared like across the whole company, or at least all the developers. Mm-hmm. But your production secrets, you don't want them to be accessible to anyone. Like only the people that need those should be allowed to access those credentials. So if they are in the code, first they will end up in many places in the code, in many computers, and also your developers will have access to it on their computer that they can bring home, that they can move to a bar or...
Right, okay. Move to a bar.
Yes. I don't do that.
We don't encourage that behavior at GitGuardian, developing at the bar. Okay, so I have a couple more questions around this. So, I mean, is the source code secure then? Can we rely on these VCS to hold our source code? And I mean, I guess the obvious one to look at is Twitch, which recently had their source code exposed. So should we kind of assume that anything in our private repositories has a possibility of being made public?
I think you always should think that everything can be public at some point. And it's more or less likely. And you should do whatever you can to hold it private. But you never know what's going to happen.
Okay, so now we have some additional maths here that I need to do. So I have been struggling with the maths of this for... so hopefully you can explain this to me. We have here in a big bold letters, 3.4 thousand occurrences of secrets are detected per AppSec engineer. So if we have 4 AppSec engineers and they're discovering 1,000 unique secrets, how do we get to 3.4 thousand secrets per AppSec engineer?
Oh, it's because it's 1,000 unique secrets, and then you have occurrences. It's the number of places in your code that a secret will appear. Like the number of files or places in your file. And so that gives us that each secret is, in average, copied like 12 times or 13 times. Wow,
okay. Now, let's have a think about this. So I'm an AppSec engineer in this company. Shout out to all the AppSec engineers watching this. 3.4 thousand occurrences. So if I do some quick maths now, I'm dealing with about 10 a day, and I'm working weekends. Is that achievable?
No, I don't think it is achievable.
And is this the only vulnerabilities that AppSec engineers have to think about?
Definitely not.
Okay, so I mean, this seems like such a mammoth task. The only thing I can think of that's harder than this is learning French. So, you know, like, is there a fundamental, do we need to make some fundamental changes to be able to deal with this amount of information? Do we need more AppSec engineers? Do we need to make less mistakes? What's the solution to how we can bring down this number?
Well, I think to bring down this number, we must make less mistakes and allow developers to have tools that help them reducing the number of mistakes first. And then they must work together with the AppSec engineers in order to solve those issues.
Right, so this is really kind of seeing DevSecOps come to life and shift left. We need to kind of all be responsible for security to help reduce that at the end. Let's have a look at some of the type of secrets that we have here. So a couple of interesting things on this graph. This is comparing public and private secrets in a number of repositories. So obviously we have a huge number more in internal repositories, but they're kind of closely correlated. You know, does having secrets in an internal repository, you know, reflect the amount of secrets that could potentially leak out in a public repository? Why are these seemingly so closely related?
That's a good question. I think having secrets in your private repositories may end up public at some point. Like, I don't know, if you're a company building an awesome project, an awesome library to help you manage your infrastructure, for instance, and you want to share it with other people because you think it's so amazing that it could really help other people's job. And if you have secrets hidden in the history, then they will end up public when you release it.
Okay, so we can see a correlation there. If we want to prevent secrets leaking being public, we got to start with our internal repositories as well. Got it. Interesting. Okay, so we've talked a little bit about solving the problem now. Let's talk further about that. We've talked about that the solution needs to be kind of widespread, but let's start with some AppSec engineers, with security teams, and move down to developers. I'm an AppSec engineer. What can I do to help reduce this problem?
Well, the first thing you have to do is to be able to monitor what's going on your perimeter, like your repositories.
Right.
That's the first thing. So using a solution that will scan your commits arriving on your VCS and maybe the history will help you understanding the problem. And then you can implement feedback loops with your developers, because with the developers you will be more efficient to solve those problems, like replacing the secrets where they are needed in the code. Like, let's say if your developers put the secrets directly in the code, they have to change the code, and they know the code, so they will be much more efficient at doing so.
Got it. Okay, really interesting. So let's now talk about developers. Okay, yeah. So GitGuardian offers solutions, and we offer solutions primarily aimed at security teams, AppSec engineers. What can developers do? How can they be part of the shift left movement?
I think if they want to be part of it, they have to automate the parts that verify that they don't make mistakes.
So it's kind of not about giving them extra things to think about. It's about giving them tools that enable them to kind of take action from this.
Yes.
Okay. And what kind of tools for developers are out there? What can we do for this?
Well, currently at GitGuardian, we have a pre-commit hook that allows any developer to have his commit scanned just before he commits those. And this is a great tool to be sure that you never have a commit containing secrets.
Okay. So pre-commits or pre-push hooks, they can be automated. You don't need to think about it, but it will block something if there's a mistake made.
Yeah. So you only think about it when there is an issue.
Does GitGuardian have a tool like that? And is it free?
Yes, it is.
Okay, that's important. Okay, so interesting. So I have another poll here that I'm curious about. So this slide on my screen here is talking about where the kind of workflow of this. So you can detect secrets pre-commit, pre-push. You probably don't need to do both. But having one, there's slight variations, there's slight advantages and disadvantages to both. We have videos on how to do this on our YouTube channel. So check that out. Make sure you subscribe to the channel. It helps the Google overlords know that we exist. And then as we kind of go down, we can see that the remote repositories, this can be for AppSec engineering teams and integrate with the GitGuardian's other products. Okay, poll time. Do you guys have any Git hooks to detect secrets? I'm really curious. So if you have a pre-commit detection, pre-push detection, you don't have any secrets detection, but you have other Git hooks, or you have no Git hooks. And if you have none on both of those, then let us know in the chat why. That'd be interesting. So we have some results here. 11 people with pre-commit Git hooks. 1 person with pre-push. I'm a fan of the pre-push. It's a controversial topic, but I'm a pre-push man. It sounds like an oxymoron for something. Let's move on quickly. And then 18 votes for no, like the honesty. Let's get onto that. What's the YouTube channel address? I'm not sure. If you type in GitGuardian, I'm sure you'll be able to find it. I'm not sure if we have a specific URL for that. But yeah. definitely in there. Okay, so really interesting. That's just a personal curiosity to me. I've wanted to see if all the videos I've been making about pre-push and pre-commit videos have been making a difference. I'm gonna take it as a personal win. 15 people have pre-commit detection. And if you don't have one, get on board Team Pre-Push. Okay, so now we've come to the kind of end of the formal slides of the presentation, and thanks everyone for being here. And we have some Q&A, so we have a lot of questions to go through. People have posted in the chat the link to the YouTube channel, by the way. I'm seeing that. So we're going to get to some of these questions now. With questions, you can upvote. So to help, so we'll kind of go with the ones that have the most amount of upvotes. But here we go. Question number 1. Now, I haven't fielded these, so let's see if hopefully there's nothing nasty in there. So why do we consider entropy for a generic password? Entropy tells whether a password is weak or strong. We should detect secrets whether strong or weak. Why do we need an entropy score? Interesting question.
Actually, to detect password, we don't use that much entropy because most of many passwords have a very low entropy.
Mm-hmm.
Like they are composed of words from the English dictionary.
Yeah.
And so if you use entropy on methods like that, you don't get good results. So you end up losing a lot of secrets.
How do we detect passwords then? And when we're referring to generic detectors and entropy, what are we detecting with entropy?
For entropy allows us to detect strings that were generated by a computer.
Okay.
Most of the API keys that you used are generated randomly by a computer, and so they will have some properties, especially about entropy, and they won't look like something that you've created yourself. I don't know, Mackenzie's super strong password 1.
Don't tell everyone my password.
Sorry.
Come on.
So we don't use entropy that much on passwords.
Okay, so we're detecting with high entropy. Now, when we're talking about generic detectors, we have specific detectors. We have 350 specific detectors. Do we just have one generic detector, or do we have like generic detectors for passwords, for entropy, for different things?
Yeah, we have different generic passwords, especially the 2 that you mentioned.
Okay.
So the generic high entropy secret and the generic password.
Okay. What are some of the difference between, say, container security scanning tool like Sneak, Anchor, Accept, and GitGuardian for container images? Interesting question again. Don't say GitGuardian's better.
GitGuardian is different.
Different. That's a good answer. Yeah.
GitGuardian scans for secrets, the container, and it scans the history. While if I'm not making any mistakes, the other scanners are scanning the top layer, so the final state of your repository, and they're not especially looking for secrets, but more for other vulnerabilities, like you're running your Docker as root, you have open ports that should be closed, and vulnerabilities like that.
So these other tools complementary to GitGuardian, not necessarily competitors in that space. Yeah. Okay, great. All right. Could the GitHub tokens in commit messages number be connected to incorrect pipeline setups?
Good question.
Oh, yeah. I have no idea, so I'm totally fielding this to you.
I have no idea. That's an interesting option. I think I'll have a look at that after the meeting.
Yep. Okay. Very interesting.
Thank you for your input.
Yeah. Thanks, Robin. Oh, we have another one from Robert. That last one was hard. I don't know if I wanted to. Robert, I'm gonna go for it. Do you have any resources? Okay, I like it already. Do you have any resources on how best to include or not to include secrets in Docker images? So actually, I can answer this one. So you may have noticed a handsome fella in the chat called Thomas Segura. So Thomas actually wrote a great cheat sheet for Docker images, how to prevent security. So this is on our blog. Thomas, give yourself a shout out. Post a link to that blog post. It's a great resource. There's a long article that explains all the steps, why they are, and there's also a cheat sheet, which is a one-pager just to help you remember this. I'm going to stop. I should have stopped sharing my screen. There we are. Have you thoughts about scanning public cloud images, AMIs? What are our thoughts of that?
Public cloud images? I don't.
Perhaps public S3 buckets or?
No, it's not something that we've done yet. Basically, we've been focusing for now on source code, but that's definitely something we could do in the future.
Yeah. Okay.
Maybe next year.
Is it possible to scan Docker images on private registries in the same way you can scan private GitHub repository?
Yeah, this can be done using the CLI tool, GG Shield. It allows you to scan any Docker image that you have and find the secrets that are in it.
Okay, great. And so we can scan Docker images. You can plug it in so that it scans the Docker image after it's created, so you can automate the process.
Yeah, of course you can automate the process in your CI, or do it manually if you prefer.
Oh, I like this next question. Is there a public API call that I can make to scan automated, to generate reports and so on? Basically, is GitGuardian exposing the required APIs?
I don't.
The question is, I believe, is does GitGuardian have an API where they can use the secrets detection?
Yeah, sure. There is one. You can find the documentation on our website to use it. You'll just have to create an account and get an API key. It's free, and then you can scan whatever text you want. Of course, it's optimized for source code, but it will work on anything.
So you can scan it. I created a video. If you're interested, of how to use this API key. There's a video on there's a tutorial on our YouTube channel. A while ago, which is me writing a little Python script to scan directories with the API key. Now, that in itself probably isn't the most useful thing to do with the API, but we did it that way because it was very clear and showed you how the API worked so that you can build your own stuff. So hopefully that helps here. Will the webinar be recorded after? Yep, we will have this webinar here. All right, last question. How do you relate a secret found in a random public repository to the company? Oh, I like this question too. So maybe I'll provide some context before you give your answer. So one of the things that GitGuardian does is we can detect secrets out in the public that aren't related to an organization. So the organization doesn't own the repository, and link that back to an organization. So how does GitGuardian do that, Henri?
Currently, I'm not working on this part of the software, so I'm not sure of the details. But mainly, it works by analyzing the contribution of a developer to the repos of the company and to the company's activity in general.
So I can jump in here for a little bit more context. So basically, what GitGuardian does is we create what we call a perimeter around an organization. So this will include all the employees, and it will also include their activity. This is all automated, so we can automatically find all the employees, and then we start monitoring the commits made and alerting if there's secrets in those. So that's kind of how we relate to it. Now, there could be personal secrets; they're not always connected to the company, but it's still good practice to not do that. So that's how we kind of cross-relate that. Okay. Are there any more questions? Did I miss any? What is the number of credentials found in code? So 6 million. 6 million this year we found in code. Anything else? No? Well, this is great. We do have more prizes, though. There was some.
Is it for me?
Not for you. I'll buy you a beer. Calm down. All right, let's have a look. at some of the most active people. So we have some swag bags to give away. So we have 2 swag bags to give away. Swag bags have some cool merch. We have Rubik's Cubes, we have hats, we have other merch in this nicely packaged box. So you can be the most stylish billboard for GitGuardian imaginable. We're going to give these away to the people that were most active. So I just have to check. Robin, have you got a swag bag before? Is that, I recognize that name. So otherwise, if you haven't, if you haven't, you've won a swag bag. But if you have, I'm going to randomly pick someone else too. But I will pick another person as well. Okay. So David's asked most active. So we have, I'm not actually sure how the analytics works, but in my control panel here, I can get a little button of people that were the most active. David, good thing you asked. That is you. So you have won a swag bag. So congratulations. And Robin hasn't either. All right, sorry, Robin. I was getting confused with another Robin. I thought I had recognized that name. So Robin and David, you are the 2 winners of the swag bag. Congratulations. Congratulations to everyone that also won an Amazon gift card. As I said, I'll be sending out emails following on from this about the process and that. So yeah, this was fun. Henri, I'd like to thank you. Thanks for sharing your expertise. We had some questions scripted, but I think like 80% of them I just threw at you. So you did fantastic. I was trying to stump you up. It was a personal game, but it didn't happen. So congratulations to you too. You've deserved your beer. And thanks to everyone that tuned in. And yeah, if you like the content, stay tuned. We will be doing another webinar at the end of March. So please look out for that. If you haven't already, like us on our YouTube channel, subscribe. That will be a great way of appeasing the algorithm lords. So thanks everyone.